So my name is Shane Glass. I am the program manager for Google Cloud's public dataset program. Yeah! But more importantly today, I get to be the MC for Demo Derby. So Demo Derby is this cool, fun thing we do internally, and it's a really neat part of our culture. Google's a really big place, and there's a lot of really cool things happening across Google. So this is an opportunity for developers and people that don't always work together to get to see the amazing work that their teammates are doing and get to better understand it. So I will get out of your way. I know you guys are here to see the fun. I'm here to see the fun. So without any further ado, let me bring up our first developer advocate, Billy.
I'll walk to the stage. Hey everybody, I'm Billy. I am in developer relations for Cloud Bigtable. And I'm going to talk to you about my demo of air quality monitoring and analysis. Cloud Bigtable is our massively scalable NoSQL database, and it's perfect for an IoT use case. So we put sensors like this in the back of a few Google Street View cars and are monitoring air quality live right now, actually. We have a few cars right on the road driving around the San Francisco area. Let me zoom in a little bit. If we wait a few seconds, we can actually watch it move around. The data is streaming in here through PubSub. We've got a 4G connector on here. It sends messages to PubSub, processes it with data flow, and then writes it to Bigtable. We also had a collection of 3 years of historical data. So we visualized that as well and created an interactive dashboard with this. Bigtable is perfect for serving an application because you get really fast writes and really fast reads. So here we're able to look at the past 3 years of data. Let me see, my zoom might be a little off. So right now we're looking at the ozone concentration. We've also have nitrogen dioxide. And these cars are driving all over the Bay Area. We can even check what happens when they go out a little bit farther. Sometimes they just stay in the area. But you can really see we're getting data at a street level precision. And this is only some of the data that I was able to visualize without the map getting too slow because there were too many data points on there. And also Bigtable, we have the really fast reads, so we're able to do training directly on our data in Bigtable. We don't have to move our data to GCS or another kind of fast storage system. So we're doing nitrogen dioxide predictions based on zip code and date. So we can click somewhere on the map and get a prediction for the nitrogen dioxide values. And yeah, and we can also change the date. Like August or something, and see if it changes. It's not, we didn't do a great job training the model. We're really just trying to show the proof of concept. Bigtable is great for an IoT workflow, great for doing machine learning on top of. Here is some of the architecture we've got going on. Let me see if it present. So yeah, we've got this beacon, streams to PubSub, to Dataflow, and then to Bigtable. And for the batch data, we can just get it streaming in right from cloud storage or maybe BigQuery. For the machine learning, we trained our TensorFlow model on Compute Engine, and then we host that with Cloud Machine Learning Services. And on the front end, we're accessing that with a Cloud Function. And this is all just being hosted on an App Engine server that's hitting all of these endpoints. Yeah, and that's all I have to demo. I think we're doing some questions now.
All right, let's have a big round of applause for Billy. Now, Billy, I was actually afraid that was a gateway computer that you were bringing over here.
Yeah.
So.
I was like, oh, it looks like a whole computer.
Yeah. So do we have any questions? We have microphones over here on stage left and right. Please come on up and ask your questions.
Now, this was the first, this week was the first day I actually got to see one of the sensors in person, so that was pretty cool.
All right, well, in that case, I'll ask a question.
All right, go ahead.
How do you guys differentiate and understand what the impact of natural disasters like wildfires are compared to what you would see in a normal kind of high traffic environment?
I'm not sure of that. So we were able to get this data from an internal team that's working with Aclima, who provided the sensors. So they're taking the more scientific initiative, doing data processing, cleaning up the data as it's coming in. We were able to just hook into their live data stream and their historical data. And they have big plans to kind of add more cars, do more analysis with that.
Yeah, so the plan is then to kind of bring this out further and expand it?
Yeah, I think in the coming months, they're going to be adding like maybe 20 cars or so. And that's just in the Bay Area. I think the goal is to expand to other areas, other countries, and see where things go.
All right, so what should the good folks here in front of us be looking forward for after that?
After that,
Yeah, like what would they see from this view as that happens?
as that happens, well, hopefully more points would be filled in, because right now we can only see where the cars are. But that's also kind of why we wanted to show the machine learning. So the cars can't be everywhere at all the time, so how can we create a heat map of where the cars might have been that past year around that time, or based on the other points around there?
Awesome. Looks like we have a question over here.
Hi. So I was wondering, with the data you've gathered, are there any sort of findings that you've concluded in terms of like health implications in certain areas of the city, or if there are any sort of, rise in asthma because there's like CO2 that's like aggregated in certain
I think there have been a few, thanks for your question, I think there have been a few more like scientific papers written about some of this information, and I don't have the answer based on that though. So I can just grab you after and point you in the right direction on that.
Any other questions? Okay, all right, well, Billy, thanks so much. We really appreciate your demo. Let's hear it again for Billy.
Thanks for having me. Can I grab this?
Okay, yeah, we appreciate your holding questions. I mean, we're asking these folks to go really fast, because that's the fun of Demo Derby, is it's a derby. So yeah, feel free to come on up during the session and kind of queue up and ask your questions. Speaking of which, we are real lucky to have our next presenter, developer advocate here at Google, Zach.
Hello, everyone. My name is Zach. I'm a developer advocate for machine learning. I'm based in London. And does anyone want to guess where my accent is from? No one has ever gotten it right. OK, that person got it right. Yeah, I'm from Ireland, and I like machine learning. And I've built a really cool machine learning detector. And it's pretty obvious what it is, right? Like, I think it's spelled correctly. So a bit about me. I'm Zach. I build stuff. I build stuff that matters. This is a decisive thing that will decide if you should eat something that's on your desk or not. You can find a bit more about that on my Twitter. But I want to talk about what I built for this demo derby. And I don't know about you, but I love tech videos. Who here likes tech videos? Like everyone, yeah, of course. I love tech videos. And I work in tech, it's great. I get to hear tech, tech, tech all day long. But when I go home, I watch tech videos, but it's just like there's too much tech jargon in them. Am I right? Like, I want to watch the tech video, I want to get all the techie goodness, but I don't want to hear about the tech. I want the tech video without the tech. Yeah? I get everyone has this sort of problem? Yeah, I want tech videos without the tech. And so, luckily, I've managed to glue together some tools to achieve this. Now, I don't know if you've been on the floor yet, but if you've been over near the AI section, we actually have a demo that shows our video intelligence API. Who here has used the video intelligence API or heard of it? A couple of people, yeah. So we had this demo, and it shows off some of the capabilities of the API. And one of them is object tracking. So it'll do sort of base object detection, and it'll do all that for you. You don't need to train the model. But it also does this cool thing, which is transcription. So if you've ever used the text-to-speech, it's basically the exact same API that runs alongside, but it just saves you having to scrape out the audio from your video file. So you give it the video, tell it, transcribe it, and it will do it. The cool thing about it is that when it transcribes it, not only does it tell you the whole block of text that is in the video, but it'll tell you a per word when each word was said at a specific second in time. So this is interesting. I could potentially use this to maybe build an app that will find the words that I don't want to hear and maybe beep them out for me. So that's cool. I could potentially do that. But hearing the words is one thing. I mean, seeing the person move their lips to the word, that's just as bad as hearing the word. Because speaking in conferences, you learn a bit of lip reading. So is there some other tool that we can use to solve this? So we have the Vision API. And what that does, if you've used it, if you upload an image of a face and tell it you're not a robot, it will detect the individual points of your face for you. And it'll do this with pretty good accuracy. So then the task is simple. We take the Video Intelligence API, transcribe it, detect the words we don't want to hear, run the Vision API, find the position of the mouth, and then with that information, we can beep out the audio and beep out the mouth. So I've recruited my friend Greg, or not Greg, oh, that's terrible. Gabe. God, it's recorded. So Gabe is a good friend of mine. I've known him years. This is him. I've taken this video today. He built this really cool Edge demo, and I got him to say, so, Gabe, what have you built?
So we built a demo that's doing vision intelligence with a model that we built in AutoML on GCP, and it compiles down to OCR classification to run on our demo. It compiles it down to the Edge TPU so that we can run it locally.
That's a great video. It's far too techy for my liking. So I've run the video through this pipeline I've created, and I enable. So, Gabe, what have you built?
So we built a demo that's doing vision intelligence with a model that we built in AutoML on GCP, and it compiles down to OCR classification to run on our demo. It compiles it down to the Edge TPU so we can run it locally.
So that's my demo. Thank you.
Hey, that's awesome. Thanks, Zach. I think that's actually the first time that I've ever seen you confirm that you're not a robot.
Yeah.
So that's actually a huge relief for me.
I had that before.
Does anybody have any questions? Crickets? You just did such a good job explaining it. That must be what it is. I gotta admit, it's not every day that you see someone forget the name of a guy with blue hair.
I know, yeah, it's embarrassing. I actually have a question for myself.
Okay, go. Please,
So, yeah.
please. I would love to hear your inquisition, sir.
Okay, so this demo was built for my specific use case of not hearing certain tech words that I don't like. The real use case that I initially came up with, as you may or may not have come to that conclusion yourself, is that in the speech transcription API, they have a little flag that will detect any profanity or swearing that's in the video transcription. And it'll label it with asterisks, stars. It'll label it with stars. So you can run the exact same pipeline that I've created here, but have it bleep out the swear words for you. So that was the original use case.
And I thought the coolest thing I was going to see this week was that picture of a black hole.
I know. Well,
this is cooler, obviously.
Of course it is. Of course it is.
Okay, was someone who does not like hearing the tech words and much prefers hearing that high-pitched beep, I really appreciate it. So let's hear it for Zach. Thank you very much.
Thank you. Do I unplug? I unplug this? Do I unplug?
Okay, Vamp. So how's it going? So I was told I wasn't allowed to do a comedy show today. Obviously, we're going to cancel the last two demos, and that's what's going to happen. So I just flew in from Pittsburgh, and boy, are my arms tired. How about that airplane food, though? Yeesh, tough crowd. All right, let's not do this. Let's go back to the demos. As we're getting set up here, let's hear a huge round of applause for the team that put together DevZone, the DevZone Theater. This was an awesome event that gave us an opportunity to get the communities together, to experiment, to categorize our pizza correctly, and to celebrate Pi Day. So huge shout out to the teams that worked so hard on that and made that happen. Without any further ado, let me get out of the way of the cat. Ben, it's all you.
Hi. So I didn't actually get the memo that we were supposed to have intro slides, and so my name's Meepy Bingo, and I'm a cat with a snorkeling thing. Anyway, so my name is Ben. I'm a developer advocate on the DevOps team. One of the things I'm interested in is monitoring, and in particular, I'm interested in system monitoring, basic sysadmin stuff. So we have Stackdriver. Stackdriver's pretty cool, but a problem that I have with it is that you only get data once a minute. So it's a 60-second interval, which is fine most of the time for historical graphs and stuff like that, but sometimes you want to know what's happening in real time. Real-time metrics are very important for debugging in a hurry, and also our brains are very good at pattern recognition. And so if we see graphs all the time, when there's an anomaly on the graph, your brain is going to recognize it because your brain knows something's not right here because it's used to the pattern that it's used to seeing. And so you can do that with this, but if you have those graphs in real time, you get that feedback much quicker. And so I've always been interested in how do you get information out of these things and into something that you can actually see in the real world. I'm also interested in doing extremely stupid demos, and so I built you this box. This is the Graphomat 3000. I know it's going to be a little bit hard to see, but I'll show you a little bit better in a second. So it's got these 9 buttons on it that light up, and they represent different metrics. So across the top, there's user, system, and I/O weight, CPU. The second row is memory usage in just regular usage, and then buffers and cache. And then the bottom row is disk and network I/O. So how many people, the developer keynote yesterday, you saw the thing about Pi? Yeah? Excellent. So I thought I'd do a little bit of that it's a good way to tax a system to really kind of show what that system can do. So I've got YCruncher here. This is what Emma used to do the Pi thing. And I'm going to run it. And I'm going to run just the basic multi-threaded benchmark. Keeps everything in RAM. And it'll start running. And in a couple seconds, we should see this went red, right? Nice. So that's telling me that I'm using a lot of CPU. So if this was just sitting on my desk, I'd be like, all right, cool, that's a lot of CPU. I don't really know what that means. So I can just hit the button and wait a couple seconds. And it's very slowly printing me out a graph. Ugh. Oh, God, that's bad. Sorry. Let's go. It's going to go away. All right, so here's a graph. Let me see if I can fix that real quick. I would like to say that in the time-tested demo thing, I didn't even have time to commit this code. You saw that we brought the laptop up here right as I got on stage, whereas everyone else already had their laptops on screen or on stage. That's because I was working on this literally until just now. All right, so here is a graph of CPU usage. Thank you. So the other thing that YCruncher can do is it can do stress testing. So you can say it's got all these stress tests built in that allows it to really work different parts of the system. And you can see those little bar graphs of this one is more memory intensive, this one's more CPU intensive. So this is just the same thing, but I wanted to show you that this box actually does something more than just that one thing. So it should be, I don't know if you're going to be able to see, it's going to be turning yellow at some point and then red as it gets started. My favorite part of demos is when you wait for something that might not happen. So, it looks like we got some colors. Yeah? Yeah, all right, cool. Well, let's get a memory graph. This kind of debugging tool is really, really handy for situations where you know that you've got a problem and your infrastructure's on fire, but you're not actually in a hurry to fix it. So here we go, little memory usage graph. So what I want, God, go away. Yeah. So what I'm interested in here is getting data out of your monitoring system and putting it in front of you in some way that's actually more useful than just having graphs on the screen. So maybe you have the classic kind of traffic light that shows your build status. maybe you have a bunch of VU meters or some kind of like displays in your office that show you the status of your system. It's important to have that stuff in front of your eyes all the time so that when something goes wrong, you see it before the computer tells you about it. So this is a stupid demo of something you can do like that, but like take these ideas and do something more interesting with them. I guess I didn't tell you how it actually works. This is really special, again, in the whole live demo thing. So what's happening is this has a Raspberry Pi in it that is tethered to my phone and is opening a reverse SSH tunnel to a machine that I have running in GCP. My laptop, I'm SSH to that machine and then through the tunnel back down to the Raspberry Pi to run stuff manually because I didn't have time to figure out how to like set them up as services and stuff like that. Net data is running on the Pi calculator machine to get real-time info. There's also data from Stackdriver, but like I said, we got that 60-second interval. So we're getting real-time data from that net data, and then we can look at the graphs from Stackdriver, and when you hit a button, it's pulling that data and printing out a graph. So that's how that all works. I really recommend not doing it how I did it, but doing something like that. So, any questions?
All right, let's hear it for Ben.
Thank you.
All right, so just real quick, how many digits of pi did you calculate?
Oh, that's a good question. Let's look.
And the reason I asked, I was doing the math along in my head. I wanted to see who got further.
Yeah, so let's see. Probably, I'm going to guess somewhere in the vicinity of 4,783.
Yeah, I got to like 6, so
Nice.
I think you
Awesome.
won. Yeah.
Cool, yeah.
All right. Any questions? All right, thanks so much, Ben.
Thanks.
All right, the last demo of the last demo derby here in the DevZone Theater. Last but certainly not least, Alexei.
Hey everyone, my name is Alexei. I'm a DA. I'm based in Paris, and I sometimes use spreadsheets. I have to admit, and sometimes I do things like that. Import and go and look, maybe on my on my file system and have some CSV, open this and then go through some formatting. Yes, I want this, and it's really error prone. And I thought maybe we could automate this. And maybe as soon as some data is ready in CSV format, I can drop this in a bucket in cloud storage. And through some magic of cloud functions, I can have this data just automatically appear in my spreadsheet. So let's see if we can get to do all of this from a project that I may or may not have been using and testing. But other than that, it has just 2 storage buckets, and that's all there is to it. It's a brand new project. And see if we can build a cloud function that will put the data straight into that spreadsheet. So the thing that I did do is enable the Google Sheets API. That's great. I said that I did have a bucket. That bucket is empty. This is where I will be dropping my CSV files. So let's actually go to Cloud Functions. How many people are using Cloud Functions? Just a few? Actually, quite a few. So let's create a function that I will call here a sheet updater. Can I type? Yeah, that looks great. This is triggered on stuff being uploaded to a bucket. So this sounds like the right trigger. Let me pick a bucket here, select that, and let's use Node, right? And let me show you a little bit of the code here. This is the default snippet. What I have is something a little bit more involved. So let's look at this. This is my function. It's an async function. It will just check that the metadata that's passed to me, which is the file that has been uploaded, is actually a CSV file. I will get some authorization and initialize a Sheets API. And then I will do a few basic things, which is create a new sheet, which is a new tab in a spreadsheet, read the data, the CSV format, and then populate the sheet. And those 2 things I can do in parallel. And do some styling and make sure I just freeze the first column, the first line. And the way this is done is fairly straightforward, especially when reading from cloud storage. The way you talk to the Sheets API is by sending JSON request, basically. So in this case, I will send something that asks to talk to this spreadsheet, which in this case is a variable that will be passed to the function as I create it. And then I have a bunch of code which is documented, and I'll tell you how to get to it. So let's actually create that function. Let's go and also express some dependencies that it requires, which are typically the storage and the Sheets API, and say, OK. I need to tell it which actual function to execute. This is function to sheet. This is what I call it. And there's one more thing that I need to do. Actually, two more things. OK, this region works for me. This thing is important. This is the service account. This is the user that will be basically accessing the sheet on the behalf of this app. So we'll get to that in a second, but remember this. What I do need to add, and this is kind of a variable that can be changed without touching the actual function, is the Spreadsheet ID. So let me type this, Spreadsheet ID. And the Spreadsheet ID is actually, if you know, this guy in the URL of any Google spreadsheet. So let's just take this and paste it here and create the function. So this will take a few seconds. The code that I have here, I can show you just briefly how it uses the Sheets API. And for instance, when I want to do some reformatting, I can do things such as give it a sheet ID, which is the tab ID that I have, and then do some styling, which is get some things that's bold, some font size, and do a number of things that might be useful here. If I go to the project, remember that service account? There's one that's created for me by default. So let's actually take that email address, which is, again, the service account that is used by the project to access the sheet, and give it access to my sheet. So just as you would invite any particular user, give it edit access, and just, actually, I'm sending this. I probably shouldn't share this. There's no human being behind. This is my project. And as I do this, let's go back to the function that has been deployed. And let's see if this thing actually works. Let's go to my bucket. And let's see if I can drop something here. Like take this CSV file, which is a few hundred kilobytes, which will translate into a few thousands or maybe tens of thousands of lines. And oh, wait, there's a new tab here. And it just takes this name, and here's the data. So what I did here is, thank you. I do have some formatting here, freezing the first row, making things bold. And that's it. My business users, or myself, can actually start and making sense and dicing and slicing the data and then using all the powerful features that Sheet offers. And that's what I have for you as a demo. And this is actually fully documented. And then there's even a code lab, so you can follow step by step through everything I just did and tailor this to your needs. Thank you very much.
All right, thanks so much, Alexei. So you said the function uses JSON to talk to Sheets. I'm glad there's a step-by-step guide. It's Shane-proof. And because I usually talk to Sheets like muttering under my voice to myself in a way that is might require Zach's demo. Are there any questions in the room? Awesome. Well, thanks so much, Alexei. And let's have another round of applause for Alexei and for all the great speakers that we had today. All right. Well, before we go, I'm going to hand it back off to Jez. But I just want to say thanks so much for coming out. We hope you all enjoyed Next. Hope you all enjoyed the demo derby and enjoyed a little piece of the Google culture. So go forth and do great things.